Azure Virtual Machine Scale Sets is an orchestrator for Azure Virtual Machines. With scale sets, you can create and manage a group of load-balanced VMs, dynamically increase or decrease the number of VMs in response to demand or a defined schedule, and safely roll out changes to your application or OS patches or even change VM types. Hi, I'm Jerry. I'm joined by my colleague, Avi.
Hi, my name is Avirisha Verma. I'm a program manager in the Azure Virtual Machine Scale Sets.
Thanks, Avi. And over the next few minutes, you'll get an overview of virtual machine scale sets and the types of problems that it helps you to address. And then Avi will give you a demo of scale sets using the Azure portal and highlight some of the latest features. With scale sets, you define a virtual machine model or template that describes the characteristics of the VMs you want to create, like the size or the type of data disks you want to use, the networking parameters, that kind of thing. You then set the instance count, and the scale set will then stamp out instances, VM instances, according to the model that you specified. And you can have up to 1,000 instances within a single availability zone. You can choose to spread those virtual machines across multiple availability zones or multiple fault domains within the same zone. You can put all those VMs in the backend pool of a load balancer, like Azure Load Balancer or Application Gateway. Once you have all those virtual machines up and running, you manage them as a unit. So a single command, for example, will turn all the VMs on or turn them all off. If you change your mind later and say you need 8 core virtual machines instead of 4 core virtual machines, you can update that virtual machine model and push that update to all the instances. And when you need to update your application or push out OS updates for your VMs, you can roll that change out to all your instances in a controlled way so that your application can keep running. Now, another nice benefit of scale sets is that it helps you optimize your infrastructure by automatically scaling as resource demand changes. So your application can change demand based on the day or the week. So to match the customer demand, scale sets can automatically increase the number of instances when that demand goes up. So say the CPU load gets very high across all the instances, or the memory gets very high across all the instances. We can scale up, and then when the demand goes down, we scale down the number of instances. So that helps to minimize the number of unnecessary VMs you have your application running on. Helps you to reduce the cost and more efficiently use the Azure resources. And depending on your workload, you can even choose scale sets that use Azure Spot VMs at a huge discount compared to the standard on-demand pricing. So as companies are really taking a look at not only moving applications to the cloud, but really embracing DevOps-based practices like image build pipelines and infrastructure as a code, repeatable automated application builds and deployments, scale sets really fits really well into that type of workflow. You can configure your scale sets with a base Linux image or Windows image, and then add your application in a post-deployment step. Or you can launch the scale set with a custom image that already has your application pre-configured on it. And of course, you can define the scale set rules and the scale set template in an ARM template, deploy via Azure Pipelines or Azure Deployment Manager. We also see a lot of people using third-party infrastructure as a code tools like Terraform and Ansible, and of course that's fine too. So scale sets gives you built-in native platform tooling for making and managing changes to your application and infrastructure while maintaining your application run state. So where do we see people using scale sets? A very classic use case is scaling out, say a specific tier of an end-tier application. Think that kind of e-commerce kind of site where I want to just do horizontal scaling over the web tier in response to some kind of event or sales promotion or something like that. We see people using scale sets as the backend for their own self-hosted Kubernetes cluster. Now Azure has Azure Kubernetes Service, and that's great, but there are some reasons where people want to have their more control more over the cluster itself, and so you can deploy that on a scale set and use the auto-scaling tools in the scale set as you increase and decrease the number of pods and nodes. We hear people spinning up scale sets to support an AI modeling job. Say, every week I want to take some information from my estate, run an AI modeling job over those so I can make some predictions for the following week. and then I want to reduce the number of instances that I use for that. I've even heard people doing things like spinning up a number of instances to do application testing, right? So instead of having one VM and running 10 tests on that single VM, I can quickly spin up 10 identical VMs and run tests across run one test across all of them. So just to speed up my application testing. One last interesting workload that we hear about on scale sets are people doing, sort of batch processing or parallelizable data mining type applications, high performance compute applications, where I just need a lot of compute very quickly to accomplish a certain task, and then I want to turn off that compute so I'm no longer paying for it. Let's go down one more level of detail and just give you an overview of some of the features that help support some of those things that people want to do with scale sets. So as we mentioned before, scale sets are based on a virtual machine model. You define a template that says what kinds of images you want to use on your VMs, what are the number of disks, what VM types, all those standard parameters that you use to define a virtual machine. And of course, you tell us the number of instances that you want. In order to simplify the management of all those VMs, the platform will help to manage all the associated resources. So as you create 100 or 1,000 VMs with 100 or 1,000 network interface cards or disks or operating system disks, the platform will help to track those. And so when you add new instances, we create those associated resources. And when you remove instances or scale down, we remove those associated resources as well. You can set the capacity, and as I mentioned before, you can also use metrics-based auto-scaling based on that model. So as your application is running and you notice that the CPU is running hot across all of your instances, you can set the scale set to automatically increase the number of instances and reduce them. And you can do that for any metric that can be captured by Azure Monitor, VM metrics, and your own custom metrics. You also get to roll those VMs out as you scale out. You can define the availability that you need for those instances. So if you want to make sure that they're spread across multiple availability zones, you can do that. If you want to have low latency, keep them close together, but separate them across multiple fault domains within that data center, you can do that too. And that's very common for stateful workloads or quorum-based databases that you may be running. Great. So you've got your application up and running on these instances. You're scaling up and down. Now, scale sets also provide some additional tooling to help you manage those VMs and the applications while they're running. So one interesting application is application health tracking and repairs. So you can help the scale sets and the instances in your applications on those instances tell Azure that, hey, this node is healthy, it's up and running how I expect it to. And if that ceases to be the case, if for some reason that node becomes unhealthy or your application breaks on that particular instance, the Azure platform can recognize that and replace that instance. When you have a new version of your application and you want to roll that out across lots of different instances, scale sets can help you with that too. You can update the image or update your application on that image, and then decide I want to roll that out in a controlled way across all my instances. And so we will roll that out across your instances. And if too many of those instances report that they're no longer healthy based on that application health tracking, we can roll that change back. So again, all the features that we have in scale sets help you to keep your application up and running and manage them no matter what scale you're using. Just touch the surface of that. And on this page, you can see the link to the virtual machine documentation where you can find out more about all the features that scale sets has. So of course, we're continuing to evolve virtual machine scale sets to provide you with even more control over your scale sets. And I just wanted to highlight a few of the new features that we've released over the last several months. These features will give you more control over the VMs running in your scale set, as well as some additional automated tools to help you maintain your application health. First, we've extended automatic image-based updates to work with custom images in a shared image gallery. So now you can have your own images stored in shared image gallery, And when you update, you update your application, you add a new version of your image, the scale sets can recognize that you've published a new image to your gallery and automatically roll that change out to the scale set. Again, in that controlled way where we monitor the application health, and if too many instances become unhealthy, we can roll that back. With instance protection, we allow you to shield a specific instance from some of those scale set actions like scale in or updates. So for example, if you have 10 VMs in your scale set and you've manually configured VM number 7, purposely deviated that one from the model, you let us know with instance protection and we leave that VM alone. And then of course, scale in policies lets you tell us what order you want VMs to be scaled in. So do you want first in, first out, last in, first out, just again, giving you more control over the platform capabilities. With instance repair, the scale set will remove instances for which the application health state is marked unhealthy and replace it with a new instance, keeping your application, automating the process of keeping your application up and running across all your instances. Finally, your applications can subscribe to terminate notifications. So if you need to, when a VM is removed from the scale set, you need to do some post cleanup operations, save logs or that kind of thing. Whatever you need to do before that VM is deallocated, that gives you an opportunity to take that control. That's enough of me talking. And with that overview, Avi is going to show you how to get started with scale sets in the portal and highlight some of the functionality along the way. Avi?
Great. Thank you, Jerry. Thanks for the introduction. And during the demo today, we will walk through three specific scenarios. First, we will create a virtual machine scale set using a custom image. Second, we will see how to monitor the application health status of each VM in your scale set. And if for some reason the application running inside the virtual machine becomes unhealthy, then we will see how to automatically repair that virtual machine. And finally, we will look at some of the capabilities that VMSS offers for safely and easily performing image-based updates. I will be using Azure Portal and Azure CLI for the demo today. All right, so let's get started. Here is the custom image that contains the configurations required by my application. As you can see, it is stored in a shared image gallery. To create a VMSS, I'm simply going to click on the button Create VMSS, which will take me to the VMSS creation page on Azure Portal. Let me provide the right subscription ID and create a new resource group for my VMSS. Provide the VMSS name and select US West 2 as the region because that is where my image currently exists. You can see that the image has already been pre-populated with the particular image definition that I'm using currently. Let me add a username and password, and I'm just going to leave the other configurations at their default values, except for a few. Let me add the initial count for the VMSS as 10 instances. I will also set the upgrade mode to automatic, which means if I make any changes in the VMSS model, it will be automatically applied to all instances. Finally, I'm also going to add a simple custom script which I want to be run when any new VM is provisioned inside the virtual machine scale set. Having done all of that, let me click on Review and Create. And you can see that the initial validations have passed. So I'll go ahead and start creating the virtual machine scale set. Now this deployment is in progress. Let's go to the resource group where soon we will start seeing the VMSS as well as its associated resources that start getting created. As you can see, inside this particular resource group that I just created, the networking resources which are needed for my VMSS have already been automatically created. I do not need to create those separately. Now, I also see that my VMSS has started to get created as well. So let's check it out. Let's see the instance list view, and I can see that all of my instances are in the process of being created right now. Great. To move on with the demo, I already have another pre-created VMSS that we can take a look at. And see some other properties of the VMSS. So this particular VMSS, I have 10 instances. All of them have been created and are in a running state. I can now go to any of these tabs on the left hand side and update the properties of the VMSs as and when needed for my deployment. For example, let me go to the scaling tab and I can again update the capacity of my scale set if I need more capacity or if I need to remove some idle capacity. I can update it right here. I can also use custom auto scale to configure scaling rules based on certain metrics that will automatically set the capacity of the VMSS. For example, I can set a rule that when the average percentage CPU utilization of the VMSS goes above 70%, then increase the number of VMs in the scale set by 1. Similarly, I can set another rule that says when the average percentage CPU goes below 30%, for example, then decrease the number of VMs in the VMSS by 1. I can also set a cooldown period, which is the amount of time that the consecutive scaling operations should wait for the scaling to complete. So that's how I can set automatic scaling rules and dynamically increase or decrease the capacity of my VMSS depending upon what my application requires. So for example, if you're using a VMSS to host a e-commerce platform which has varying demand throughout the day, you can set these automatic scaling rules and you don't have to worry about manually changing the capacity. So for now, I'm just going to leave it at 10 instances. And let's move to the next section of our demo, which is we would like to monitor the application health of each of these instances. For that, I will go to Health and Repair tab and I will click on Enable for application health status. Now I will provide the details of the specific port where the application health will be monitored for each VM. Once I click Save, this new model of VMSS will be applied to each of the 10 VM instances in the scale set. And we will soon see that the application health of each VM will start getting monitored and reported. Great. So now the application health monitoring has been enabled on the VMSS. Let's go back to the instance list view. Let's hit refresh and here you can see that the health state is getting reported and all of the instances are in a healthy state. Now let's try and simulate one of these instances with an unhealthy application and see that how does the VMSS react. For that, I'm going to use another VMSS where I already have simulated a few instances as unhealthy. Now, in order to automatically repair these unhealthy instances, I will go back to the Health and Repair tab and enable the automatic repairs policy. So I'll click on the on button and leave the grace period as 30 minutes. The grace period is important because whenever any VM gets newly created or recently updated in the VMSS, we want to allow it some time to come back to a healthy and stable state. And only after that, we would like to perform further repair actions. So now that we have enabled the automatic repairs, let's take a look at the instance list again. And you can see that one of the unhealthy instances got deleted and the VMSS automatically created a new one to replace it. And on refreshing, we can see that the new instance has come back as a healthy instance. So this is how VMSS provides a capability to automatically maintain a set of healthy instances in your scale set and repair if any of those VMs are found to be unhealthy. Now for the final part of the demo, let's look at the capabilities that VMSS offers for performing image-based updates. Image-based updates can be easily rolled out to the VM instances through an automated availability-first approach. For this, let's go to the Operating System tab and enable automatic OS upgrades. Having done that, whenever a new version is available for the custom image in the shared image gallery, VMSS will automatically detect that and start updating the VM instances in batches. During this process, if the updated instances happen to become unhealthy, which could happen if the new image version has some issues, then the VMSS will pause the new image rollout and will roll back the instances to the previous image version. Let's simulate this behavior by adding a new version of our image to the shared image gallery. But before we do that, let's use another VMSS feature called the instance protection policy. For example, if you do not want one of these instances to be updated to a new version, you can simply select it and apply a protection policy. I'm going to apply the protect from scale set actions policy in this case. If I only wanted to protect this instance from scale in operations, I would have chosen the other protection policy. So as we can see that particular instance is getting updated and the protection policy has been applied on that instance. So I will go to the Azure CLI and run a command to show the exact image version that has been used to create my instance ID number 14, just as an example. As you can see, it is created using the 1.0.1 version. And now I'm going to add the image version 2.0.1 and also make that available as the latest image version in my gallery. So we can now see that the image version 2.0.1 is now available as the latest image version and will start getting rolled out in the VMSS instances. So now let's check that the VMSS instances have been upgraded to this new image version. For this, we can use another CLI command to view the automatic OS upgrade history. As you can see here, there have been 3 instances successfully upgraded so far, 5 are pending, and 1 instance is in progress. Let's go back to the instance list view, hit refresh, and see. As we can see that there are a couple of instances which are in the process of being upgraded to the newer version. Let's go back and check their exact version now. It should show up as 2.0.1. There you go. The instance ID 16 is now using image version 2.0.1. However, the one that we protected from scale set actions, our instance number 14, should still be on the older version of the image 1.0.1. All right, so that was the end of our demo. Thanks a lot for watching, and back to you, Jerry.
Thanks, Avi. So Avi walked us through a few different scenarios for scale sets. We saw how to create scale sets with a custom image and quickly launch a number of VMs with that model. We saw how to change the number of VMs managed by the scale set, either manually or based on metrics. We saw how we can use scale sets to help control and manage all those VMs at scale, sort of using the scale set APIs and its orchestration to manage all the VMs as a single unit. And we saw some of the new features that we've released to help you give you even more control over the instances and the applications you run on scale sets. Now, this was a relatively brief introduction to scale sets. We think it's very helpful, and we hope that you find it helpful too. And I encourage you to take a look at some of the links here on this screen. so you can learn more about scale sets and see if and where it would help you with your applications and your organizations. On behalf of Avi and myself, just thank you very much for your time.